Good day, everyone. Today is another beautiful day, and you are welcome to the Physics branch of Mathematics Solutions Center. Today, we are going to be looking at a topic which is simple harmonic motion, in abbreviation SHM. In this topic, we are going to be learning about the various formulas of simple harmonic motion and how these formulas are gotten. And also, we are going to look at how to apply these formulas to solve problems in simple harmonic motion. Let's go. We want to use this opportunity to plead with you that you should kindly subscribe to our YouTube channel, like our videos, share it. What is simple harmonic motion? The motion of a body or particles along a straight line such that the acceleration of the body is directed towards a fixed point and is proportional to its displacement from that point. Let me show you a video of how a simple harmonic motion looks like. Now take a look at the motion of these two objects. We have a red ball moving in a circle, and the blue ball, the only type of motion the blue ball is observing is just a kind of a to and fro motion. So that means there's a relationship between an object that is moving in a circle and an object that is moving to and fro. That means the motion of an object moving in a circle can be likened to the motion of an object that is moving to and fro along a straight line. So let me remind you the definition of simple harmonic motion again. Simple harmonic motion is defined as the periodic motion of a particle along a straight line such that the acceleration of the particle is always directed towards a fixed point and it's directly proportional to the displacement of that particle from that fixed point. That is simple harmonic motion. A periodic motion simply means a motion that repeats itself at a regular interval. Look at the motion of the ball round the circle. It is a kind of a repetition, and this is taking place at a regular interval. That is why it is a periodic motion. Periodic motion simply means what? It is occurring at a regular interval. The motion of the blue ball is also a simple harmonic motion because it is occurring at a regular interval. Now, if I may give you or ask you, what are examples of a simple harmonic motions? The thick ball is moving up and down while the dotted line ball is moving in a circle and they are meeting at a particular point. This is simple harmonic motion, and all these things are related. Now we are going to define some of the parameters that are associated with simple harmonic motion. Take for instance, we have a ball that is moving in a circle. This is the ball at this particular point, and this is the ball at another point. Let us call this point M, and here the second position of the ball to be point N. If this ball should move from point M to point N, it has moved along the arc covering a distance of S. And the angle displaced is given by theta. Now, is there any relationship between theta and S? Now, what we are talking about here, we are talking about the linear displacement and we are talking about the angular displacement. These are two different things, but they are also related. We have a formula connecting both of them. What is the formula connecting angular displacement and linear displacement? Let us draw the sector of the circle formed as a result of the movement of the ball. This is my S, while this is my theta. Here is the radius. Here is the radius of the circle. From normal algebra, we know that the length of arc is given as theta over 360 times 2 pi r. This is length of arc in terms of theta and radius of the arc on which the object is moving. So, but in this topic, we are dealing with the measurement of angle in radian, not in degree. This formula is correct when you are talking about a degree, when the angle theta is measured in degree. But if you are measuring theta in radian, then you have to change the formula. Some things need to be changed in the formula. To measure in radian, we will take pi to be equal to 180. We will change 180 to pi. Then we have converted from degree to radian. So what are we going to do? From S is equal to theta over my 360 is the same thing as 2 times 180. Then times 2 pi r. Therefore, I have S is equal to theta over, since 180 is the same thing as pi in radian, that means I have 2 pi times 2 pi r. Pi cancel pi. S is equal to theta r or r theta. This is the relationship between theta and the radius of the circle in which the object is moving. Now let's define what is theta. We know that S is the linear displacement. Linear displacement is the measure of separation between 2 points. But when we call it displacement, we say that it has direction. But let's just give the basic definition of distance between 2 points. Now we are going to talk about theta. What is now theta? Theta is the angular displacement of an object. Theta is the what? Angular displacement of an object. The same way we have linear displacement, we also have angular displacement. Now let's talk about velocity. The velocity of an object is the distance traveled over time. So we can say that velocity is equal to the linear displacement over time. What about angular displacement? If I'm going to talk about angular displacement, then I'll talk about angular velocity. Angular velocity is equal to angular displacement over time. Then in case of next time, if somebody asks you to define velocity, the question you are supposed to ask the person is, what type of velocity are you asking me to define? Because we have two different types of velocity. We have linear velocity and we have angular velocity. Linear velocity is equal to linear displacement over time. While angular velocity is the angular displacement over time. Now we want to generate the relationship between angular velocity and linear velocity. Don't forget we've gotten that S is equal to R theta and V is equal to S over T. That means V is equal to R theta over T because S is equal to R theta. Therefore, V is equal to R times theta over T. But theta over T is equal to my angular displacement. Therefore, V is equal to R omega. So take note of that. V is equal to R omega, while S is equal to R theta. We've gotten the relationship between velocity and then omega. Now, when an object is moving in a circle, this object possesses both velocity, acceleration, which is always directed towards a fixed point. Going back to the diagram, we want to generate the acceleration under normal condition. We have two ways of generating the acceleration of an object moving in a circular path or observing a simple harmonic motion. We've already gotten that V is equal to R omega. But don't forget that acceleration is equal to V over time. Acceleration is equal to R omega over time. R is a distance. Therefore, R over time is actually velocity, then omega. So we've gotten another formula for acceleration. But acceleration can also be given as, because V is equal to R omega. If I substitute this in place of V, my acceleration becomes what? Omega times omega R. Therefore, acceleration is equal to omega square R. This is another formula for acceleration. As a physics student, you must know how to relate one formula from one form to another. These are linear acceleration in relation to what? Angular velocity and then the radius of the circle through which the object is moving. Now let's look at another approach and go into more detail. From this diagram, let's draw a line vertically downward. Let's draw some line vertically downward. Let's say this distance is x. Here is A. That means we have something like this. This is my x. This is my A. This side will be the y. This side will be equal to square root of A squared minus x squared. X is the displacement of the object at a particular time t, while A is the amplitude, which is the maximum displacement that is possible for an object that is moving along a circular path. Let's evaluate cos theta. Cos theta is equal to x over a. Therefore, s is equal to a cos theta. But don't forget that omega is equal to theta over time, angular displacement over time. Therefore, the angular displacement is equal to omega t. We are going to substitute this in place of theta. I have s is equal to a cos omega t. This is what I have. Now let's find the velocity. Velocity is equal to the rate of change of displacement with time. So if we should differentiate this expression, we have minus omega a sine omega t. This is the expression for the velocity. But don't forget, initially we proved that v is equal to r omega. This r is the displacement, while a is also equivalent to r. It's just that we have used another letter to replace a. So in a situation whereby sine omega t tends to 1, then that is when we have v is equal to r omega. On what condition with sine omega t equal to 1? That is when the angle is maximum. And when is the angle maximum? When omega t is equivalent to what? 90. That is when the angle is maximum. At that particular stage, the velocity resort back to this initial value we calculated. But at any given angle, this is the formula we use to calculate the angular velocity. Actually, this particular velocity I'm talking about here is not actually a secondary school level, but you just have to know it for knowing sake at this particular stage. I think for your stage, for those of you in secondary school, this is the formula that you are limited to use for now. Now we have our velocity to be equal to minus omega a sine omega t. Let's find acceleration. Acceleration is equal to the v over the t. Therefore, if we differentiate this again, I'm going to have omega square a cos omega t. S is equal to a cos omega t, as written before. Therefore, acceleration becomes minus omega square s. This is the formula for acceleration. V is equal to r omega can be written as v is equal to omega square root of a square minus x square. Take note of this formula and be careful when you are using it. If x is equal to a, that means the velocity is going to be minimum. Velocity tends to 0. And then if x is equal to 0, when is s is going to be equal to 0? And then velocity is going to be maximum. Let's go back to the diagram. If this object should move and get to this particular point, the displacement of the object we assume to be moving along this straight line to and fro, just like that blue ball. The total displacement will be 0 at the center here. At the center here. Therefore, we have v to be maximum at the center. But at this end here, this is when x will be equal to a. So the velocity is minimum here, while the velocity is maximum here. The next thing we are going to talk about is frequency and then period. Let's start with period. What is period? Period is the time taken to complete one revolution when an object is moving along a circular path. If this object completes one revolution in 3 seconds, that means the period of this object is what? Is 3 seconds. Don't forget, period is also measured in what? In seconds. We have omega is equal to 2 pi over the period. Because we know that omega is equal to theta over what? Over time. But for one revolution is 2 pi. Don't forget, one revolution is 360 degrees. So one revolution is the same thing as 2 pi. And if it is one revolution, that means that is a period. The time taken to complete that one revolution is a period. Therefore, omega is equal to 2 pi over period. Then let's talk about frequency. Frequency is the number of completed revolutions in 1 second. If an object completed 3 revolutions in 1 second, therefore it is what? frequency. That is the frequency of the object. It has 3 frequency, 3 hertz. Frequency is measured in hertz. So frequency is the reciprocal of a period, and period is also reciprocal of a frequency. Omega is equal to what? 2 pi f. Don't forget we wrote that omega is equal to 2 pi over t. Therefore, omega is equal to 2 pi times 1 over t. And 1 over t is actually frequency. Therefore, omega is equal to 2 pi f. Let's take an example. A boy ties a stone to the end of a string, which he then winds about his head around a circular path of radius 15 cm. If the stone makes 20 oscillations in 10 seconds, calculate the angular and linear speed of the stone. The radius r is equal to 15 centimeters. The number of oscillations is equal to 20 oscillations. Time is equal to 10 seconds. When we say 20 oscillations, it means the object goes round. How many times? 1, 2, 3, 4, 5, 6, 7 to 20. That's what we mean by 20 completed oscillations. So the question is what? Calculate the angular and the linear speed of the stone. What's the formula for calculating angular speed? Angular speed is omega. Omega is equal to what? Theta over time taken. That is omega. The angle taken over what? Over time. Angular displacement. What is the total angle taken? 20 oscillations, 20 completed circle. And one circle is 2 pi. That means we have 20 times 2 pi over the time, which is 10 seconds. 10 goes there. We have 2 left. The angular velocity is given as 2 times 2 pi, that is 4 pi in radian per second. The next question is the linear velocity. Linear velocity is equal to r omega. What is my r? It's 15 centimeter. I have to convert it to SI by dividing by 100, then times my omega, 4 pi. 4 goes there 1, 4 goes there, I have 25. Therefore, V is equal to 15 pi over 25 and is equal to 3 over 5 pi. V is equal to 0.6 meter per second. Let's take a look at another question we have here. Solution. A spiral spring makes 60 revolutions. Number of revolutions is equal to 60 rev. 50 revolutions. In 15 seconds, T is equal to 15 seconds. Find the period and the frequency of the vibration. The period and the frequency. So if you can remember from the formulas we derived, omega is equal to 2 pi n over time. We have omega is equal to 2 pi n over time. N represents the number of completed revolution because omega is equal to theta over time. Now the theta depends on the number of completed revolution. If we have 2 revolutions, the theta is going to be 2 pi times 2 revolutions. 1 revolution is equal to what? 2 pi. So from this, let's calculate our angular velocity, which is equal to 2 pi times 60 revolutions divided by 15. So from this, I have omega is equal to 2 pi times 15 goes in a 60 is 4. Therefore, omega is equal to 8 pi in radian per second. But don't forget the definition of a period. Period is actually what? The time taken to complete one revolution. The time taken to complete one revolution. So you can use this formula. V omega is equal to 2 pi over t. 2 pi is 1 revolution. So the time taken to complete 1 revolution. What is my omega? 8 pi is equal to 2 pi over period. Therefore, t is equal to 2 pi over 8 pi. From this, I have that t is equal to 1 over 4 seconds. That is the value of t. Another way through which you can calculate the value of t without using this formula is for you to use relation. From the question, we have that 60 complete revolution in 15 seconds. An object completed 60 revolutions in 15 seconds. What will be the time it will take this same object to complete one revolution? 60 revolutions in 15 seconds. Then what will be the time that will be required to complete one revolution? Then we cross multiply. From this, I have t is equal to what? 15 times 1 over 60. Therefore, I have my t to be equal to 1 over 4 seconds. Using this relation, I don't need to calculate my angular velocity before I calculate my period. I will just relate 60 and completed revolution in 15 seconds. What is the time that will be required to complete one revolution? Once you get the value of your period, then you can calculate the frequency. Frequency is equal to 1 over period. Therefore, frequency is equal to 1 divided by 1 over 4. That is reciprocal of 1 over 4. The reciprocal of 1 over 4 is actually 4 Hz. We've calculated the frequency and we have calculated the period using two different methods. The amplitude of a particle executing simple harmonic motion is 5 cm, while its angular frequency is 10 radians per second. Calculate the magnitude of the maximum acceleration of the particle. Solution. We have the amplitude. Amplitude is the maximum displacement from the mean position. That means that is the radius, 5 cm, which is equal to 5 over 100 meters. The angular frequency is 10. Omega is equal to 10 in radian per second. Calculate the maximum acceleration. What is the acceleration? Acceleration is equal to omega square r. From this question, our omega is 10 squared times 5 over 10. That is our r. Therefore, I have 100 times 5 over 100. 100 will cancel 100. Therefore, the acceleration is 5 meters per second squared. We have come to the ending of this tutorial. In our next video, or if time permits us, we are going to pick various questions on simple harmonic motion and we will solve it and produce the video for you to see. Thanks very much for watching. Please kindly subscribe to our YouTube channel so that we'll be motivated to do more of things like this. Like our videos, share it, and then put on the notification button for you to know when next we are uploading the next video. Solve this question and put your answers in the comments. I am going to attend and reply why your answer is correct or wrong. A stone wide at the end of a rope 30 cm long makes 10 complete revolutions in 2 seconds. Find the angular velocity, the linear velocity, and the distance covered in 5 seconds if the rope cuts.